Okay, today we're going to look at some techniques to improve your computer vision that allow you to speed up your robot and the efficiency of the way in which your robot drives. Okay, what I've done now is I'm not only looking at how far offline the robot is, which is the blue mark down there. I come all the way out here, I'm over 200 offline to the left. I come out here, it tells me I'm quite far offline to the right. As well as looking how far offline I am, I'm going to look at the angle the line is at. The angle will tell me what the future trend's going to be. So if I'm out that side, I'm over 100, somewhere around about 180 off to the side, but my angle to come back is 14, 15 degrees. So what it means is I don't really need to turn back much because it has a trend of coming back. If I'm out to that side and the line is showing more straight up, what it's telling me is that the future trend of that line is to go fairly parallel. So if I'm out to that side and the trend is to stay the same, it means I need to actually turn back. If I'm out to that side and both the angle is negative and where the error is negative, it means we're heading in the wrong direction and I need to turn back quite a lot. The other thing that this does is as I'm coming up to a corner, before I get to the corner, it starts to angle out and tell me that the future trend of the corner is to go out that way. And that allows the robot to cut the corner a little bit in order to get a little bit better speed and efficiency. Okay, so now let's look at some code in order to do that. At the moment, the program is very similar to how it was halfway through the first lesson. We capture our image array, then we're going to say the black line is equal to the in range of the whole image, not just the region of the image. We erode it away, we dilate it out, we find our contours. We say if we find any contours, we're going to find the bounding rectangle, which you guys are familiar with. The bounding rectangle will return the x and y coordinate of the top left hand side of the rectangle and the width and the height. Then we're just simply going to draw that rectangle in color blue so we can see it. Then what we're going to do is something you guys haven't seen before. We're going to find the minimum area rectangle. And what this does is it rotates the rectangle until it can find what angle can make the smallest possible rectangle fit around it. Alright, and we're just going to make the array black box store all that information. Down here we read that information from the variable black box. It's going to give us the x and y coordinate of the center of that rotated rectangle. So it doesn't give us the top left hand corner like bounding rectangle, it gives us the very center of that rotated rectangle. And it also gives us the width and the height, and it also gives us the angle of which it's been rotated at. Alright, I've then just turned that angle into an integer, i.e. just cut off all the decimal places so it's a whole number. Then to draw that minimum area rectangle in, there's a couple of ways you can do it. You can actually find the corner points and draw 4 lines, or I can turn it into a contour and draw it as a contour, which I've done there, and I've drawn it in red. I've then also, in the top left hand corner of the screen, just simply shown what the string version is of the angle, so you can see the output of the angle. And then of course I just show it on the screen and around we go again. So let's have a here he is in action. So you're used to seeing the blue box, the bounding rectangle, and we know that the center of the line is halfway in the middle of the bounding rectangle. But as well as the bounding rectangle now, we have this minimum area rectangle, and you can see it rotates the rectangle around till it can find the minimum size rectangle to get around it. And then in the top left hand corner, I'm actually printing out the angle that it's giving. Alright, now what happens is it always rotates it clockwise till it manages to get it square. So at the moment it's had to rotate it clockwise 78 degrees to be square. So it's telling us it's at negative 78 degrees currently where it is at the moment, because to go to clockwise it needs to go 78 degrees. When we're at this side here, it also says negative 9 degrees. And as we keep going out further and further and further, It's the same thing, he goes out more of an angle, and he will always return an angle between -90 to 0. If it's 0, it means it hasn't been rotated at all. If it's -89 degrees, it means that it had to rotate it in a clockwise direction for 89 degrees to get the square, so in its current position it's -89. Okay, I've just modified the code slightly. All I've done is I've removed where we look for the bounding rectangle and draw the bounding rectangle out, because we're not going to be using bounding rectangles anymore. We're just going to use the minimum area rectangle. And now, because of the way the angles work, we're going to say if the angle is less than -45, then angle will be equal to 90 plus angle. That's it. That's if it's gone further back. Otherwise, it just equals itself. All right. And then when we run that program, what we'll find now is we just get the bounding rectangle, and what happens is if the rectangle was more than -45, it doesn't do anything and it just prints it out and it's correct. But what happens is if we got to this side out here where it had to rotate it more than 45 degrees, it just did that little calculation and changed it to be right. So now when we're out on the positive side, it's saying positive angle by how much we are out, and we get back less, it says less and less and less than this angle to a square, and as we come out the other side it says negative. Now that works quite well for angles up to 45 degrees. Once we start getting more than 45 degrees turned, you can see what it does is it then comes back again. So when we're just under -45, it does it correctly. Once we go around to anything more than 45, it goes back to being positive. We'll do the same on the other side as well. If we come out this side, we turn him around, he works quite fine. Do we hit 45? Once we hit more than 45, then it says negative numbers and the wrong amounts. So that will give us the correct amount up to 45 degrees out. Okay, I've added a couple more lines of code. Just from working at the angle, I'm going to say now, if the width is smaller than the height and the angle is less than 0, then the angle will be equal to 90 degrees minus the angle multiplied by -1. If the width is larger than the height and the angle is smaller than 0, then the angle will just be equal to 90 plus the angle. That's to fix the problem we have when we're more than 45 degrees. We'll see that we're more than 45 degrees by looking at the difference in the width and the height. And then we know which side we're on depending on the sides of the angles. So when I come back and I watch this in action now, what you'll find is if we're less than 45, it works exactly the same as we did before. It does not change anything it does. But once it gets more than 45 degrees, if I start bringing him out here, so go more than 45 degrees now, you can see he keeps going on and keeps going on and keeps going on. The same if I come out the positive side, if I come around here, we come right out the positive side. So we start to hit 45 degrees, you will find it just keeps going. So now we can detect angles up to 89 degrees off instead of just 45 degrees off. Okay, just a tiny bit of cleaning up of the code at the end. I've set my set point for 320 because that's halfway across the 640. I'm saying my error is my X position minus my set point, because minimum rectangle, the X and Y coordinates it gives you, is actually the center of the X and Y. I've just turned it into an integer, i.e. cut off all the decimal places. And then what I've done is down here, I have also writ that error to the screen down the bottom left hand corner in blue, and I've also put a little bit of a line where the center of the box is going to be, just so we can see. Seeing it all in action now, final at the end there, I've got my little blue line that's going to be in the center of the line no matter where it goes out. You'll see that it tells me what my error is from my set point, and it also tells me the angle of the line. So now I have the angle of the line and the point there. So obviously you guys can then drive your motor off those inputs.